Let's understand the concept of maxima and minima in economics. So we will see how to find the maxima or minima for a function. So the steps of the optimization are very simple. What we need to do, first step is to set first derivative equal to 0. Okay, set first derivative equal to 0. Okay, if this is our function, we have to maximize total revenue. Our total revenue function is being given here. We have to find out the maximum total revenue and the value of quantity and total revenue also. Okay, first step is set first derivative equal to 0. Okay, so that means that this is our total revenue. Its first derivative is simply d dr upon dq. That means change in total revenue with respect to quantity, and we set it equal to 0. Okay, so when we set it 0, so this becomes 400. Derivative of q is 1, so 400 into 1 is 1, minus derivative of q square is 2q, so 2 becomes coefficient, 2 8s are 16. We have 16 q, and this exponent is subtracted by 1 by per function rule, and we set it equal to 0. Okay, after that let us solve it for q. So we have 16q is equal to 400, which gives us q is equal to 400 upon 16, which comes out to be 25. Okay, so the steps of optimization requires first we set the first derivative equal to 0. After that, second step is find second derivative. Okay, find second derivative. Okay, if second derivative is if second derivative is greater than 0, then we have minimum. If second derivative is less than 0, then we have the maximum. Okay, actually I have explained this whole step, maxima or minima, in my earlier video series on the differentiation. There you can also find this, so I'm just giving a gist here. Okay, so we got the value of q is equal to 25. Now to check whether it is actually maximum or not, what we need to do, we need to find out the second derivative. So second step is to find second derivative. So this is our first derivative, this is the first derivative, then second derivative is d square of total revenue upon dq square. Okay, we need to find the second derivative. This is the first derivative, and second derivative will be the derivative of this first derivative. Okay, so derivative of 400, which is constant, is 0. Derivative of q is 1, so we are left with minus 16. Here we can see minus 16 is less than 0. Okay, so rules of optimization tells us if second derivative comes out to be less than 0, then we have the maximum. Okay, that means q is equal to 25 is at maximum. Okay, now to find the maximum total revenue, so as we know, total revenue is simply equal to, this is our total revenue, just plug the value of q is equal to 25, which we got here. So we have 400 into 25, then we have minus 8 into 25 square. This comes out to be 10,000, minus 25 into 25 is 125, so we will get here 125 into 8, which comes out to be 5,000. Okay, I'm not sure about the calculation here, so we have 5,000 as maximum total revenue. Okay, so simple thing in optimization, what we do, if we are being given the total revenue function or profit function or any function, to check whether we got the maximum value or not, we just need to set second derivative. Sorry, to check, we need to find out the derivative. If it came out to be less than 0, then we have the maximum. And graphically, what does this mean? If we have quantity on this axis, total revenue on this axis, if this is our total revenue function, okay. Now first derivative ensures that slope is equal to 0. When we find out first derivative and set it equal to 0, that means it is this point here, okay. Simple thing, when we take the first derivative of total revenue, which is our marginal revenue, this gives us the slope, okay. When we set slope is equal to 0, okay, we got the value of q is equal to 25, and this could have been like this also. So first derivative does not tell us whether we are at maximum or minimum. It simply tells that slope is 0. Slope can be 0 at this point or at this point, okay. Now to differentiate whether this point is minimum and this point is maximum, we need to take the second derivative, okay. So if second derivative comes out to be less than 0, that means slope is decreasing here, then we are actually at maximum, okay. If second derivative was greater than 0, then the case would have been minimum, because the slope is increasing from this point, okay. So second derivative ensures whether we are at maximum or minimum, okay. I hope I make myself clear in this video. Thank you.